Hello class, this is a video tutorial on the parametric form of a function part 3. In this video we'll be looking at trigonometry and circles. By using the trig identities cos theta equals x and sine theta equals y with the equation of a unit circle x squared plus y squared equals 1, we can write circles with any center hk with any radius r in parametric form. So we're going to look at circles with any center h and k with any radius, and we're going to see how it converts into these two expressions for x and y in parametric form. Notice how x is related to cos and y is related to sine because of this relationship there. So let's get straight into a example of this. So here we go. So first is we need to convert this into a radius of 1 for now. So looking at this one here, we're going to do this by dividing by whatever this value is. So we're going to get x squared on 4 plus y squared on 4 equals 1. Converting this, we get x over 2 all squared plus y over 2 all squared equals 1. And then from here, since this is of the form x squared plus y squared equals 1, we can say that this is x squared. So all of this is x. And since cos theta is x, we're going to take this expression, let's highlight it here for us. Take that expression, because remember that is now x squared. That is now equal to cos theta equals x on 2. From here, we're going to add multiply by 2. 2 cos theta equals x, or x equals cos theta. That there is our first parameter for x. We're going to do the same thing for y. Let's grab a different color just so you can see it. All of that is now going to be y squared. And since sine is y squared, we can say sine theta is equal to y on 2, multiplying by that 2. 2 sine theta equals y, or y equals 2 sine theta. And that there is so these two combined make the parametric form of this equation here. So it's very straightforward. Hopefully that gave you an insight into this. So you can try it now with a different center. So first we're going to change once again this into a unit. So x minus 2 on 9, this is still squared, plus y plus 3 squared on 9 equals 1. Making this into all squared, so x minus 2 on 3 all squared plus y plus 3 on 3 all squared equals 1. In case you're confused as what's happening here, I'm just reversing what happens when we expand indices. So this goes to the numerator. It'll become x minus 2 all squared, and this will become 9. I'm just simply reversing that process. And now we have this in unit circle form because it's a radius of 1. taking that and using cos and sine for x and y. So we now get x equals, x minus 2 on 3 equals cos theta, because remember cos theta equals x, and in this example x is x minus 2, but in this example x squared is x minus 2 on 3 equals cos, multiplying by 3, adding 2 plus 3 cos theta. And there we have it. As for this one, we do the exact same thing. Y plus 3 on 3 equals sine theta, multiplying by 3, and this time minusing 3. Minus 3 plus 3 sine theta. These two combined make the parametric form of this equation here. Okay, let's do one last example. For this, we need to first make it into unit circle form. So for this, I'm going to rearrange this first. So I moved the constant over and left some space for completing the square. Taking half of this and squaring it. So half of 2 is 1. Squared is still 1. Half of negative 4, so actually no, we need to add 1 here. And half of negative 4 is negative 2. Squaring that, negative 2 squared is plus 4. Completing the square here, now we get x plus 1 all squared plus y minus 2 all squared. 4 plus 1 plus 4 is 9. And now going through the entire process again. X plus 1 on 9 squared plus y minus 2 on 9 squared equals 1. Making it into all squared form like this. Whoops. Minus 2 on 3 squared equals 1. We can now say x plus 1 on 3 equals cos theta. And doing multiple steps in one go, x equals minus 1 plus 3 cos theta. And for y, we get y minus 2 on 3 equals sine theta. Y is equal to 2 plus 3 sine theta. And that there is the parametric form of this circle. So just to keep the video a little bit short or shorter, I'm gonna stop at these 3 examples from converting from Cartesian to parametric form. Actually, looking at this, hopefully you can adapt what you know to convert it from parametric back to Cartesian form. We'll do 3 more examples for this in the next video. Hope to see you then. Best of luck.